In this chapter, we're focused on graphing linear equations. A linear equation is an equation with two variables like this, y and x typically is what we see, that we can graph on a rectangular coordinate system, which we have seen also. The important part of this is that both variables, y and x, have a degree of 1. Meaning we're not squaring y, we're not squaring x, we're not raising them to a fourth power or whatever. It's just a y, it's just an x, and see here we're not multiplying them. We're not dealing with any variables in the denominator. We're just talking about a degree of 1, and we know how to find a degree of a polynomial. So in order to sketch a graph of this, y equal to minus 2x plus 1, we need to plug in points. We need to find points, plug in values for x. So we have our x-axis and our y-axis, and all of these ordered pairs, or all these points that are on this rectangular grid here, they're going to have a relationship of minus 2x plus 1 between the x's and the y's. And it's only the x's and the y's that have this relationship that we will see on the line. So in order to find some points that are on this line, we need to plug in different values for x. And once we plug in different values for x, we can see what y is, and then we can sketch those points. So I'm going to choose to plug in a minus 1, a 0, and a 1. Don't really need to plug in more than that. We'll get a nice general idea of what this line will look like. So those are my x's that I'll plug in. When I plug this into my x, I'm going to see what I get for y. So minus 2 or negative 2 times negative 1 is a positive 2, plus 1 is a 3. So this point here is a negative 1, 3. So I'll plot that right here. When I plug in 0, negative 2 times 0 plus 1, that gives me a 1. So this point is going to be 0, 1, which is right here. And when I plug in 1, negative 2 times 1 plus 1 is a negative 1, because you get negative 2 times 1 is a negative 2, negative 2 plus 1 is a negative 1. So this point is 1, negative 1. That's going to go here. We can now draw a line between these points, and that's not so bad. But we need to connect those 3 points with one line, and now we can see that this line is made up of not just those 3 points, but an infinite number of points. And those are the ordered pairs, the x's and the y's, that are going to satisfy this equation. So if I were to randomly pick any point here, and I can't really do it here because it's not such an accurate line, but if this was an accurate line, I could choose any ordered pair that was on that line, plug that ordered pair into my equation, and it would be equal. That's what makes this a line. It's the set of ordered pairs that satisfies this equation.